Okay, now for some pre-calculus review. Solve these equations, of course using algebra. With this one right here, we're probably going to need to use the quadratic formula. So that would be x is negative b plus or minus the square root b squared minus 4ac divided by 2a, where this is going to be a, b, and c. Alright, let's get to it. It's going to be x is negative b plus or minus the square root of b squared minus 4, the a, and the c. All divided by 2 times the a. And then we would have, let's see, this right here is going to become positive 16 times 2. So we've got a 25 and a 32. 16 times 2 is 32, and 25, that's going to be 57. So x is negative 5 plus or minus the square root of 57 divided by 8. So with a 57, there's no perfect squares that can be factored out, so technically we could be finished right now, or if we wanted to get decimal answers, we could use negative 5 plus the square root of 57, and then that's divided by 8. Do the same thing with subtraction in between. So a 0.319 or negative 1.569 in decimal form. Now for this second one over here, we're going to be squaring both sides in order to get rid of the radical, but you need to isolate the radical first. So what I'm going to do is I'm going to move it to the right-hand side, or in other words, add the square root of x to both sides. So it's going to equal a positive square root of x, then square both sides. So on the right-hand side, that's simply going to be an x. On this side, we would need to square the first thing. That's going to be x squared. The middle term comes from multiply this with this, and then double the result. So multiplying will be negative 12x, double will be negative 24x. And then 12 squared is 144. So this one is quadratic. We're going to need to use quadratic formula again, but we need to get everything on one side, so subtract x from both sides. There's x squared minus 25x plus 144 equals 0. And I doubt that it can be factored, so use quadratic formula again. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times the a. And we could just go ahead and have 25 squared minus 4 times 144. Oh, very nice. Turns out to be a 49. That means that we can take the square root of it. If we could take the square root of it, that means this could have been factored. Oh well, we've done the quadratic formula already. That's okay. So we would have 25 positive plus or minus the square root of 49, so that's plus or minus a 7, and then it's divided by 2. So a 25 plus 7, that's going to be 32, divided by 2 is 16. And then if you subtract, that's going to be 25 minus 7 is 18, divided by 2 is 9. Then you have to check your answer when you do this. Whenever you square both sides, it's possible that you do all of the algebra right, yet one of these answers is not correct. Or it could be even that both of them is not correct. It could be that both are right, but you have to check. So if we take these numbers and put them back into the equation, that's one way to check. By the time you're in pre-calculus, you should be using a graphing calculator to check. It's a y equals negative x subtract the square root of x plus 12, and then see where does that equal 0. So that is the answer 9. If I change the window to go out farther, say to 20, is there going to be an answer at 16 as well? No, the 16 is not going to work. So if you check, it's going to be the 16, it's going to be negative 16 minus the square root of 16 plus 12. Does that equal 0? So this would be a negative 16 subtract 4 plus a 12. Does that cancel out and give you 0? This is going to be negative 20, and positive 12 is negative 8 equal to 0? No. So this one does not work. And then if you check the 9, it's going to say negative 9 minus the square root of 9 plus 12. Does that equal 0? Well, this is going to be negative 9 subtract 3 makes negative 12 plus 12. Yep, that one works. So the 9 is a keeper, but throw away the 16.